A key advantage of PAS Professional is that it provides RF-centric design capabilities.
You asked and we're answering. Whether you attended one of our past professional RF webinar events live or watched the recording on demand, a lot of questions were asked. So let's get the answers. Hi there, I'm John McMillan, and welcome to this special series of PCB Tech Talk podcast, the After the Webinar series. In this special podcast series, I'm joined by webinar presenters as we answer and discuss the questions submitted by attendees during our recent webinars. As always, be sure to subscribe to this podcast. Let us know the topics you'd like to discuss, and if you'd like to be my guest right here on PCB Tech Talk. Today, I'm joined by the RF webinar demo presenter, Brent Klingforth. Hi, Brent.
Hey, John, it's good to be here. Glad to see we were able to help people out there with another great webinar on RF PCB design.
Yeah, it was great. It was well attended by both European and North American sessions. We answered lots of questions in the time that we had, and we also had some questions left over. And what we're going to do is we're going to recap the Q&A that we actually addressed in the European sessions if you were on the US, and the US sessions if you were on the European, and also any questions that we did not get to during the live webinar. For those people that didn't attend the RF webinar, Brent, why don't you just give a brief overview of what you covered during this session?
All right, John, I'll do a quick recap. So the webinar was covering, RF design, but we covered a lot more during that as well. So we started out showing the product that we're replacing a communications board from a lower frequency wireless communications to a higher frequency wireless communications. So starting out, we went into the schematic. We showed using PartQuest some of the new capability in VX 2.7 actually of drag and dropping data into the tool to make it much easier to bring in your data from PartQuest, adding that part to the design. We then moved on to creating the actual printed circuit board, showing the mechanical engineering side of it and how the mechanical engineer actually created the board outline for us, obviously, which is the best thing to do. Bringing that directly into PAS Professional using the industry standard IDX transfer. Then went in, placed the board, got into the details of actually doing the RF side of it, communicating. In this case, we used Keysight's ADS simulation tool to define the patch antenna that we're using in this design. So we showed the integration from the ADS tool into PAS Pro Designer and then transferring that information into the layout. Did some stuff on placement related to RF and regular components as well, and then got into the details of actually routing RF nets, setting up some design rules related specifically to RF objects, dealing with stitching vias around those objects, around the plane areas that are around the objects, dealing with the stack up in order to determine a 50 ohm trace or not. After the routing portion was done, we then went back to mechanical because obviously the mechanical engineer wants an update as to what we did with our part placement. Are we going to have any part collisions with the case or not? So we sent a file back over to the mechanical engineer with all the 3D models that we had placed in the PCB so he could have a real look at the mechanical design. From there, we pretty much had finished the entire design. We wrapped it up and we're here answering questions now.
Yep, perfect. Thanks, Brent. And also, just so you know, if you happen to miss the webinar, it's now available on demand. You'll be getting a link in the email if you registered for it. If not, you can go to pads.com and it'll be one of the resources available on demand. So if you want to, you can listen to this podcast, then go and check out the on-demand webinar. So let's jump right into the questions. Go ahead, Brent. Why don't you get started?
All right. First one here is, are these RF traces that you've routed in the design using 45-degree bends? So you should not use 45 or 9-degree bends in high-frequency RF. As shown during the demonstration, we use large radius arcs. Another method is to use mitered 90-degree corners. Both these types of corners features are part of the meander routing capability with PAS Professional's RF capability.
Yeah, that's a good point. So along those same lines, when a question came in, can individual RF segments be moved and parametrics adjusted? And that's a really great question. And though all these details weren't demonstrated in the actual on demand, you can actually move individual RF segments. That is, the ones that are available for arrangement. You can also utilize the auto arrange feature to automatically arrange RF sets of segmented circuitry. So I'll just run through some RF specific layout features. You can import complex RF shapes. You can do ground stitching vias to shield RF circuits. You show some of that actually in the on demand. Restrictive clearance rules for specific to RF. You actually point some of those out. Automated RF circuit arrangement and grouping. Meanders, you talked about this just a little while ago with rounded and chamfered corners. Via stitching, you actually demonstrate that for easy creation of coplanar waveguides, and flood regions with vias according to designer rules. Now, with regard specifically to parametrics, going in a little bit deeper into RF design, you can also change RF specific parameters and properties. That is, ones that are editable using the RF parameters and properties dialog. And if needed, you can also modify and add specific variables to RF elements within the variables and equations dialog. So again, these are RF-centric and specific layout capabilities. Good question.
All right, thanks, John. Another one here is the ground copper spacing from the RF traces part of the rules? Yes, like we showed in the demonstration, the RF capability in PADS Professional provides special rules for copper objects tagged as RF. These special rules include RF shape to traces, vias, component pads, planes, and solder mask opening. So some of the capability that John just talked about there.
Here's another great question. When you see the on-demand or if you saw the webinar live, you noticed that the MCAD tool that was utilized for collaboration was with NX. The question is, do we work with different MCAD tools? Great question. So in addition to Siemens NX, the other MCAD tools that support the IDX ProStep IVIP schema file exchange format for real-time collaboration are PTC Creo, SolidWorks, and CATIA. So you have NX, Creo, SolidWorks, and CATIA are all supported with this data exchange format. Good question.
Let's see. I think there's another one that goes along with that. Yeah. Are these new RF functionalities also available in Mentor Expedition? Yes, both tools have similar functionality, and all capabilities shown in the demonstration are also available in Expedition as well. Let's see. Another one here. Do those rules come in ADS or PADS Professional? So simulation tools like ADS are meant to define the rules that we would use in a PCB, much like a signal integrity tool would be. So once the RF engineers performed their simulation, decided on the proper parameters to produce the proper performance of the antenna, they can provide the PCB designer with those values, which will then be entered as RF rules in the layout. So taking advantage again of what we showed in the demonstration, very specific RF object-based design rules. So unlike most other PCB design tools that don't have RF specific capability, where you have to define a rule based on, an entire section of a net, RF objects can be obviously part of the actual routed net, which is again kind of what we showed in the demonstration.
Yeah, great question. Next question is, how do you know if you're working on an RF PCB? That's an interesting question, but a good one. So in general, if you're new to RF design or even microwave design, the general rule is boards that operate above 100 megahertz tend to be RF PCBs. Boards that operate above the 2 gigahertz range is classified as microwave PCBs. So that's a good way to determine the tool capabilities that you'll need supported.
All right, let's continue on here. Can I create a library based on RF objects with vias included? Yes, PADS Professional Footprint Library functions very much like a PCB. This also allows you to add all the same objects that you would in a PCB, like copper, planes, traces, multiple via types, drafting objects, mounting holes, keep outs, etc. So the library capability inside Professional is very comprehensive, unlike a lot of other CAD tools in the industry. Let's see another one. When using ADS, can changes be made to a shape and then be pushed into the layout? Yes, I actually showed this during the demonstration. So yes, the integration with Keysight ADS is bidirectional. Once an internal copper shape has been brought into the layout, this establishes a link to the RF project. Now, when a change is made in ADS or to one or more RF objects, those updates can be automatically annotated into the layout. I showed that with one of the patch antennas where we were in the ADS layout tool. The engineer modified the width of the antenna, and then using the automation, I simply pushed that into the PCB tool so that we didn't have to modify anything individually or import DXF files and do replacements and those types of things. So that is a very big advantage of using the Keysight ADS tool. And we also support Microwave Office or AWR. With the ADS, I could go in and use the parameters that John spoke about earlier to change a transmission line and then push that information back into ADS.
Gotcha. Brent, for a student that's looking into getting into PCB design, specifically with RF, do you have any particular resources that you would recommend?
So yeah, there are a lot of resources out there. Obviously, using the Google machine, you can find a lot of information. But here's a couple things that I did find that I found very useful in me learning some of these things about RF design. Is Maxim has integrated RF tutorial that has general guidelines for RF and mixed signal PCBs by Michael Bailey, which is really good and free to look at. Semtech has an RF design guidelines for PCB layout and circuit optimization, which is also good. There's a lot of online resources like magazines, microwave101.com or Microwave Journal are good places to get information constantly about what's changing in the world. And also they have webinars and such for training. Another one you would go to is RF chip vendors. Just about every RF chip vendor out there has some type of app note based on their device or training materials available on how to do proper RF layout, at least for their components. And then a big one that no one should forget about that is very much a big feature or component of an RF PCB is the material itself. It actually becomes a much more critical function in the layout than most PCBs. So going to websites like Rogers or Isola or AGC Nelco, they have app notes. And I know Rogers for sure has been doing a lot of webinars of late with 5G coming out. The high-speed materials that need to be used for frequencies that we're going to be running in the 5G space now. 6 gigahertz all the way up to 100 gigahertz. So a lot of good resources out there. Check out some of those and see if that's a good starting point for you.
Good answer. I'll take the next question. Somebody asked, will the tool allow us to make modifications in imported footprints? And the answer to that is yes. Footprints, or cells as they're called in PADS Professional, can be edited on the fly, actually. And this includes all the features like silk screen placement outline, pad position, and pad geometry. So that's another really good question.
Yep. These next two kind of go together. I'll read both the questions and then kind of provide one answer for both of them. But what method is used to calculate 50O microstrip or coplanar conductor backed waveguide? And if we go with microstrip, is there a rule for ground copper spacing? So for traces we routed in our demonstration, we used a stack-up editor to help calculate the trace and distance to the coplanar ground plane. So for imported RF objects, these were simulated and defined in ADS. So yeah, again, as we mentioned, using the stack-up editor to help calculate the impedance of the portion of the traces that you're routing that didn't come from ADS will give you all the right answers. And I think I had another one that goes along with that about materials. Yeah, how do we handle materials? There are plenty of RF materials out there. How often do you update your material library? The stack-up editor does not have any materials to choose from. However, it does include all the parametric information in very, very detailed parametric information that you can enter from, say, a data sheet from a PCB materials vendor's data sheet. So let's see. I think I had another question here on materials that would go along with this. Yeah. How do you handle materials? There are plenty of RF materials out there. How often do you update your material library? So currently, the stack-up editor does not have a materials library available to you. However, it has all the proper parametric properties where you can enter information off of a vendor's data sheet. Once that's been entered into the stack-up, you can then save off that design, say as a template with that stack-up information that you can then use on future designs. So you do have a way of reusing that content, so you're not reproducing it each time you want to create an RF design. So John, let me ask you a question. How does the RF tool handle a signal that has to transition to the other side of the PCB?
Thank you for the question, Brent. You can define a specific via geometry in your library and then use that for trace transition or in the patch antennas so you can have access to internal layers. This is done by selecting Add Via from the RF toolbar, placing it, then routing a meander to and from the via. Good question.
How should I calculate the distance between stitching vias and the signal trace? Well, this calculation is generally the same as the copper to trace if you're doing copper flooding around your RF elements. So for a trace routing from the PA, the power amplifier, to the first RF element that would have come from our simulation, you need to maintain a 50 ohm impedance on that trace. So if you're using a coplanar ground plane, you can use a stack-up editor to help you determine that. If required near the antenna, the proper calculation would need to be done by your RF simulation tool, or your RF engineer would actually do that part. And they would probably give you the plane area and the via information near the patch antenna if that was required. because that would be very, very specific to the functionality and of how that antenna is going to work. So that would all have to be simulated.
So the next question is the direct import of symbols from DigiKey available also in Expedition VX.2.1? That's interesting. It's a very specific release. Also, is 3D vision of the imported component available? Yes. Expedition has all of the same capability with PartQuest as it does with PADS Professional. You only need to configure PartQuest for Expedition. So this includes all the symbols, the footprints, and 3D models supplied by DigiKey and its partners. And there are both symbol and part wizards now in PartQuest in case a symbol isn't available.
All right, I think our last one here is, how are RF elements structured in the library, like the one based for XDM? So RF elements are mainly parameterized objects, meaning an item like a trace feature only needs a symbol with RF parameters. John mentioned this earlier, and it's how data is actually transitioned in from ADS. We supply a basic library with the tool, or you can create items as needed. If using ADS, you can create the item in ADS and then create the library for PADS Professional. If you import an RF object via DXF, you can create a symbol based on that RF object from the layout tool, and it will make a symbol exactly like it is on the PCB for the schematic. So they look very much alike.
Well, that wraps up the questions, Brent. Thanks again for joining.
All right. I want to say thank you, everyone, for joining the webinar. I hope it was useful, and look for more content like this coming in the future for PADS Professional and other products.
Thanks, Brent, and thank you for joining me for this special After the Webinar Series podcast. For more information on this podcast, as well as links to the on-demand replay of the webinar discussed, be sure to check out the show notes. There you'll also find additional information related to this podcast, along with my email address, so feel free to send me your comments and questions or any topics you'd like to hear me talk about, or if you'd like to be my guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, iHeartRadio, Stitcher, or your favorite podcast app, and be sure to catch the next episode of PCB Tech Talk.